Hey there guys, welcome to the start of a brand new playlist on past paper exam questions all about sequences. In this video we are covering arithmetic or linear sequences. In the next few videos in the playlist we will cover geometric, Fibonacci and for higher tier quadratic sequences. So the playlist will be linked down below. Make sure you download the PDF of this one because I've made this revision sheet covering the different types of sequence. Let's do this. Okay then, first up, great question to start sequences on. So here we have sequences on the left, we want to match them to the description on the right. So the top one, 1, 1, 2, 3, 5, 8, is indeed Fibonacci. We are adding the previous two terms to get the next. Okay, then we got 1, 2, 4, 8, 16, 32. So there we're multiplying by 2 each time. So this chap is geometric. Now, on the right, where they say progression, progression means the same as sequence. Okay, then the next one, 1, 2, 3, 4, 5, 6. We are adding a 1 each time. So that's arithmetic. Okay, now the next one, 1, 3, 6, 10, 15, etc. may not look familiar yet. So let's go on to the next. So 1, 4, 9, 16, 25, 36. Those are our square numbers. And then 1, 8, 27, etc. are cube numbers. So that must mean 1, 3, 6, 10, etc. are the triangle numbers. So, okay, now for anybody wondering what triangular numbers are, if you have a triangular number of things, they can be arranged into an equilateral triangle. So 1 doesn't show it very well. Then we got 3. And then we got 6. And then we got 10. And they carry on like that. Okay, next up. Time to term rule of a sequence is to add 8 and divide by 2. The first term is minus 24. Work out the next two terms. So to work out the second, we need to do minus 24 add 8, which is minus 16. And we then need to do minus 16 divided by 2, which gives us minus 8. And then the next term, we do minus 8 add 8 is 0. And then 0 divided by 2 is 0. Okay, then for part B, the term rule of a different sequence is to subtract a 1 and multiply by 5. The third term is 120. We want to work out the first term. Okay, so to go backwards through the sequence, we go backwards through the row. So we're going to divide by 5 and then add 1. So 120 divided by 5 is 24. 24 add 1 is 25. So that's the second term. Then to find the first, we do 25 divided by 5 is 5, and then 5 add 1 is 6. Okay, next up, the nth term of a sequence is 3n add 4. Explain why 21 is not a term in this sequence. So there's two ways we could do this. Either find the first few terms and go past 21. So for example, the first term would be 3 times 1 add 4, which is 7, and then we'd have 10, etc. Or the clever way to do it is if 21 was a term, then 3n add 4 equals 21, which leads us to a whole number value for n. So if we subtract 4, we get 3n is 17, which would tell us n is 17 over 4. But n has to be a whole number because it's the term number. Okay, then we're given the first 3 terms of a sequence, 1, 2, 4, and we're asked to give possible values for the 4th and 5th terms, giving the rule we have used. So, there's 2 that I see. The obvious one would be 8 and 16. And then the rule would be to multiply by 2. Or the other one would be 7 and then 11. So what's happened there is the difference is going up by 1. So 1 add 1 is 2, 2 add 2 is 4, 4 add 3 is 7, 7 add 4 is 11. So for the rule for that, you could say something like add 1 more each time. Okay, then we are given the first 4 terms of an arithmetic sequence, and we want to find the nth term. So the first thing we need to know is what the sequence is going up by. So we are adding 6 each time. That tells us the nth term is something to do with 6n. Now, if we use the first term, n is 1, so 6 times 1 is 6, we need 5, so we need to subtract 1. And then we can check it's right. Let's try with the second term. 6 times 2 is 12, minus 1 is 11. Okay, now we're doing the same thing with another sequence, 11, 21, 31, 41. So here we're going up in tens. So the nth term is something to do with 10n. Now again, if we use the first term, n is 1, 10 times 1 is 10, we need 11, so it's 10n add 1. Okay, next up, the first term in a sequence is 24, the term-to-term rule is add 8. Josie says no number in this sequence is in the 5 times table. Part A, give an example to show she is wrong. So the next term would be 32. The next term after that would be 40, which is in the 5 times table. Then for part B is 85, a term in this sequence. Give a reason for your answer. So the easiest way to do this is we are starting on 24, which is even. We are adding 8 each time. Now an even number add an even number always gives us an even number. So the answer is no, and the reason would be what I just said. Okay, next, the term-to-term rule of a sequence is to add 4 and then divide by 2. The first term is 36, work out the third. So the second is going to be 36, add 4, 40, and then 40 divided by 2 is 20. So then for the third, 20, add 4, 24. 24 divided by 2 is 12. Okay, then for part B, the term-to-term rule of a different sequence is to divide by 3 and then add 10. The second term is 60. We want to work out the first. So again, we have to work backwards through the rule. So subtract 10 and then multiply by 3. So 60 minus 10 is 50. 50 times 3 is 150. Okay, next up, the fifth term of a linear sequence is 17, the sixth is 21. We want to work out the hundredth. So to do that, we are going to need the nth term. So to get from the fifth to the sixth term, we have added 4. That means the nth term is something to do with 4n. Now, if we use the fifth term, n is 5. So 4 times 5 is 20, but we need it to be 17. So 20 minus 3 is 17. So the nth term is 4n minus 3. Now we can check that with the sixth term. 4 times 6 is 24, minus 3 is indeed 21. So the hundredth term is 4 times 100 minus 3, which is 397. Okay, next up, a sequence of patterns is made using circular tiles and square tiles. We have the first 3 patterns. Part A, how many square tiles are needed to make pattern number 6? So, let's see. So, pattern number 1 needs 1. Pattern number 2 needs 4. Pattern number 3 needs 9. So these are our square numbers. So the number of square tiles needed is the square of the pattern number. So 6 squared is 36. Part B, how many circular tiles are needed to make pattern number 20? So, in the first one, we needed 4, then we needed 8, and then 12. So this is actually just our 4 times table. So number 20 will need 4 times 20, which is 80. Okay, then for part C, Derek says when the pattern number is odd, an odd number of square tiles is needed. Is Derek correct? You must give a reason. So the number of square tiles needed is the term number squared. So when you square an odd number, you get an odd number. Is Derek correct? Yes. Okay, next up we have the first 5 terms of an arithmetic sequence and we want to find the nth term. So we are going up in 5s. So the nth term is something to do with 5n. Now, for the first term, which is 3, n is 1. 5 times 1 is 5. So to get 3, we subtract 2. Check it works with our second term. 5 times 2 is 10. Minus 2 is 8. Boom. Okay, then for part B, the nth term of a different sequence is 3n squared. Nathan says that the fourth term is 144. Is Nathan correct? We must show how we get our answer. So, bit mass is important. We need to do 4 squared first. So, 4 squared is 16. 3 times 16 is 48. So, is Nathan correct? No. What Nathan's done is he's done 3 times 4 is 12, and then 12 squared is 144, which is not correct. Okay, now the final question, we have a sequence of patterns made with counters. We want to find an expression in terms of n for the number of counters in pattern number n. So find the nth term. So the first pattern has 4 counters, then 7, then 10. So we're going up in 3s, so the nth term is something to do with 3n. Now for the first term, n is 1. 3 times 1 is 3. We need 4, so it's 3n add 1. Let's check it. 3 times 2 is 6, add 1 is 7. Cool. Okay, then for part B, Bayo, awesome name, has 90 counters. Can Bayo make a pattern in this sequence using all of his counters? So if he can, then 3n add 1 equals 90 would have a whole number solution for n, because n is a term number. So if we subtract 1, 3n equals 89. Now 3 does not go into 89. So we would get n is 89 over 3, which is 29.6 recurring. So because that is not a whole number, the answer is no. Alright guys, that's it for this one. Really hope you found it useful. If you have, please do give us a thumbs up, subscribe to the channel, share with your friends. Remember to check out the sequences playlist, which is linked down below for geometric, Fibonacci and quadratic sequence exam questions. If you have any requests for topics you want done like this, let me know down below in a comment. For now, take it easy, take care.